Hi, I am Thibaut and I will show you how to build a model from scratch inside the Peccary Shiny app. So you have to click on model building for that, and here you have where you will write your model. So we'll just see how to write a model by hand. So it's basically just a deSolve system. So which is actually the key syntax of Peccary. So you have, for instance, the dx equal minus ka for x, and the concentrations, which is equal to x divided by volumes of distributions, and then you click on load model, and so you see that it is exactly like in the Monolix systems, where you have two times. First, you just write your structural model without any considerations for the variability, for the error model, or something like that, and then Monolix prefill for you some table, and here it's the same thing. So it prefill what are the compartments of your model, so here x, and you can then choose what is the initial values of these compartments. Here you can choose the parameters, so if you found two parameters, ka and vd, you will have to select some values for them, and then the distribution is if it's log normal, or if there is no variability, so we will have to add other distributions, and then you will have a not mandatory column, which is just mentioned if the parameters will be estimated, will be fixed, or if it's actually not a parameters but an input from the datasets. You have the variance covariance matrix, and here you have your protocol administration based on the event systems of the deSolve packages. So you just say at time 0 on variability on the compartment x, I had, for instance, 50. You can add if you want variability by clicking on here, or you can TLAC. So for instance, if I click here, I had a TLAC parameters, and I can choose if it's actually a perfusion and not an instant administration. And then below in plot and simulations, what you can see is that you have the load plot here, and you can click on them to just load the plots that you want. So here you see that it will print everything that is checked here. So you can just display x, but actually what you want is the concentration. So you have two possibilities, either to add plot or to add output at the end of parameters of the thing that you want to print. So you click on load model, and here you will see that you will have the concentration available, and so if you click now on that, you have the two systems. So this is the first way to write a model by hand, but most of the time what you will use is library. So let's say we want to do a model for a Simeone or tumor growth inhibition model. So here you have the PK and here you have the PD. So what you can do is, okay, remove that and say what I want is a PK, which is a monocompartmental PK. So you can do just that, which is the same thing. And then you want a PD, and then you have the PD, and you see that the PK is directly used in the PD, so the link is directly made. And then you click on load model, and you will have to prefill everything. So I will just prefill this and come back in a few seconds. Alright, so I have filled all the information. Just notice here that I have put a number as an initial value. If you want a baseline parameters, you can explicitly write it on the model by saying that I want a baseline. You reload the model, and then now you have your baseline here, and baseline being a parameters. Actually here it has to be just a formula that return a number. So for instance, if you have k in k out models, with k in k out being parameters, you can write that, so a real formula, and it will work perfectly. So here we have a baseline, and then you have below plot and simulations, and you can click on load plots, and you will have your plots loaded. So here you have a table where you can click on whatever you want, and let's say you click on everything, and you will have every parameter that you want, every compartment that you need. So here it's quite messy, so we will click here on output, and it says we will wrap it with the output, and you can see your dynamics of your model. What you want then is the concentrations, and you see that concentration is not proposed here. And if you want to see your concentrations, you need to add either plot or output. So let's add output and click on load model, and you see now that concentrations has been added here, and so if you reload the plot, you will have your concentrations. And because you say output, it's also here on the table when you can register your error. If you just write plot, it's the same thing, but you will not have here the concentration added in this table. So you see how easy it is to add a plot and to look at all your dynamics of your models. If you are working with a project, don't forget that you can save it. So let's say I want to save it in Simeoni, and you see now here that you have the models, which means that if you close and reopen your Peccary project, now you have to, well, load, of course, your project, and when you go back in model building, now you have your Simeoni, and if you click on load, everything is pre-filled back to what you just watched, and so you can re-have your plot as it was before. So it's very important. But now we will see what is really why the system is so great, I think, is because here it's not just a number, but actually it's a vector that has to return, it's air code that has to return an atomic vector of numerics. So let's say you want to try different values of one of your parameters. Well, let's say for instance K2, what you can write is, so an air code, so here with C, and say we want to try all these values for the K2. Click on load plot, and what you have then is how every compartment is affected by modifications of your parameter values. Another thing here, you see that you go below like 10 minus 8, so it's very absurd values. So what you can write here is like, I don't want to go below that. And if you click on load plot, you will see that you will have a minimum value displayed. And it's the same thing here. If you don't want to go higher to certain values, then you can just write, I don't want to go higher to like 10,000, and then what you will have is that you don't go higher to 10,000. So this is the first thing. What you can do then is add some points. So let's say we want to add the points of concentrations and tumor volume. So we have to check out that we have the right data sets, but it's the case. And then we know that concentrations is Y type equal to 1, and tumor volumes is Y type equal to 2. And we click on load plot, and you see that you will have all your information added to the plots. So sometimes it's not really the point is added on above the lines, but it might be modified in the future. So you might see whether you had on the right kind of values or not for your parameters. What you can also do then is, like, let's say we just want to look at the tumor volumes, but what you want is to try different protocol. So before doing that, I will just show you one other thing, that you can actually you have another ways to write a model is directly by importing it from a model. So actually the simulated models, I have made it. So example demo. So I've made the models on Monolix, and so here you have an nlmixr. You can just copy the nlmixr, open from scratch a Shiny app. So let's do that. Go on import model, then you pass that and click on launch. And so if you do that, Peccary read all the files from the nlmixr models, he wrote the models here, and he added the final values of the parameter estimations. And so what you can do then is, okay, this is the concentrations and the tumor volumes. You can add the plot, the points. So if you click on that, you will not have the points from your data set, but you will have your points from the folders directly. And then you can just click on that, I want my points, and I will have that. And what you can do here is, so by default you have the population values, but what you can do is also say, I want specifically the values of the, let's say, ID1. And you see that the values change, but also the protocol. So here is a patient without, without any dose, but let's move to that, and you see that everything has been modified. And if you click on that, you will have specifically this patient. So here, you see here that it will not go up to 100, just because here, so if you want to expand the simulations, you have to click on that. What will be the modifications if actually one value, for instance, like say that, and then here you are. So you see that you can retake any values from what you want. But let's take so the population values. Let's remove the points. So we have that, and let's say now that we want to see the evolutions of different protocols. So we want to try different protocols. What you can do is go there and say, I want to test. So here, for instance, what happened, if we don't have any administrations, and here we will try something quite little different. We will try to inject like time 0, time 24, and time 88 the dose of like 25 milligrams. So here it has to be also a hair code returning anatomic vectors of numerics. And if you do that, what you see is that you will have, so you have to click on use, and if you do that, and you have to change the protocols, of course, so protocol 1, protocol 2, protocol 3, otherwise, so here in fact it's the additions of all the lines, and if you have different numbers of protocol, then what you have is that. So here we don't want to have a value which is too high, so let's go up to 1000, and you see your different protocols, number 1, number 2, and number 3, with different lines. You can also do simulations. So if you want to do simulations, let's say we want 20 simulations, for instance, then you just here, so here you will have simulations making, and then you have to write. So if you have that a maximum value, it will fail, so you have to remove the maximum values if you want to do the plots, and then so it will be improved, and after some modifications we might do that, but if you have an issue, it might be that for the moment. Just have to wait a little bit and you will have your simulations here. So you don't see that much, so what you can do is doing the wrap by events, and now you will have that. In the meantime, what you can observe is that everything, for every plot that you have here, you will have the code, the independent error code that produce the plot that is here. So here you see the different protocol administrations. So here it is actually the error code that produce exactly that. So let's, for being quicker, if you want to print that in a report, for instance, like Peccary is not validated, and so you can't have a complete trust by default on Peccary, and what you can do is verify that Peccary did not make any mistakes, and you can also put that on a report, and so as Peccary is not validated, it's not really an issue. So you click on that, and you say, so let's do that. So pass that. To show you that I'm not cheating, I will erase everything. And so now if you do that, well, you will end up with the exact same plot. So this is how Peccary is so potent, because you can create a model from scratch from the library or from already existing Monolix or Nonmem files. You can import them, then you can do simulations, you can modify the parameters values, you can modify the protocols, you can try lots of things. And then what you can do is, let's reopen Peccary, is doing some translations. So let's go back to demo. So and reload Simeone. So if you have that, then if you want to launch a Monolix, if you want to do a Monolix estimation, you can just click on that, and then click on Launch Audio Translations, and you will have your code in the Monolix syntax that you can just take and then use for the Monolix systems. And if you want to do a non-mem models, you can just click on that, and you will have your non-mem model on that. You can choose to have or not the mu replacement. So if you do that, you will not have the mu replacement. If you want to add the BLQ values, the BLQ block, you click on that, and then you will have the additions of the BLQ block. You see here that you have two outputs, so you have YTip equal true, and there is nothing. It's because you have to add there the Y type regarding your datasets, so say 1 and 2, and then if you have that, now you will have the launch audio translations, and you will have that. So it's not perfect, and sometimes, like for instance here, you don't have the right input for the moment, so it has to be input, but in any way, it's much more faster to use Peccary to create that. And because you can import a model, for instance from Monolix, you can import a model from Monolix and then translate it into Nonmem, or the opposite. So you can translate any syntax into any syntax because of thanks to the system. So it's pretty interesting, I think. And the final things will be the optimal design. So the optimal design look like that. So actually, for the moment, it's not optimal design; it's only design evaluation with Puppet. So here you say, okay, I will measure my tumor volume, for instance. So I have my first group, which has the protocol number 1. So it has this protocol, and my time sampling is that. So here 1, 5, 10. With this additional error. So if there is an F, it means that it is not estimated. So let's estimate at least the proportional error. And here it's quite the same things. Like let's say you don't want to estimate psi, you had an F here, and you cannot estimate it. And if you don't want to estimate a parameter, so you say click on here and fixed or input, and it will work like that. Then you click on eval designs, and then you just wait, and you will have the design evaluations. You will see the numbers of the evaluations, and then you have the code right there. So here also is a Peccary independent code. So it's a code you will have written to create the Puppet analysis. You can just take this code and use it in a report or things like that, and you will have the whole Puppet things. If you want to add, like, let's say you also have concentration values, you can add them, and well, let's do that. And here you have both concentrations and output. You can change protocols, so you can have different groups and things like that, but I think I will do a video specific on that, but you can begin to play with that if you want. So I think this is pretty everything for model building for the moment, for at least the first levels. So here also you see that I didn't mention everything. I did not speak about that, for instance. So the how you how you handle coverage, and I will do optimal design specific video and things like that. But I think it's a good way to have a quite short video for the first Peccary handling. Don't forget that Peccary is a collaborative project, which means that everything can be improved. It's the package belongs to everyone. I will do some video to explain how all this works. So every function is where you can find it in the Peccary source code. So if you want to improve the systems, you can do it by looking at this video and see where you have to do modifications. I think this is everything, so goodbye.